the main project files, the hardware abstraction layer, crypto files, and simple serial. Okay, so I think this is a good setting for the audio. So what I'm going to be working on today will be building an experiment for performing an attack on XOR encryption using the ChipWhisperer Nano. So I'd like to build an extremely practical, workable experiment that allows for beginners to explore the concepts and technical implementation of encryption, firmware development, side channel analysis, and ChipWhisperer products. Particularly the Nano in this case is what I'll be using. I've already started developing a Jupyter notebook within the existing ChipWhisperer lab directory that is available. ChipWhisperer Nano Jupyter notebook. So I'm going to pull up the GitHub just to show you what I mean. So this is the project that I've been going through in each of my episodes, going to courses in SCA 101, and I've gone through these different experiments. I think the last one I did was dynamic power analysis on firmware, implementation of AES. This was the last one I've done. And so I think the next time I do one of these, it'll be power and Hamming weight relationship. But recently I felt like I wanted to change it up and work on an experiment of my own, which will be implementation of XOR. So in this stream, I'm kind of just going through the process of building an experiment. So I have some tabs pulled up of some information that is relevant. And these tabs are custom firmware on ChipWhisperer targets, which is what we want to consider because we are creating an experiment. Well, I'm creating an experiment where I'm implementing the XOR encryption. And simple serial is the communication protocol for communicating between the ChipWhisperer capture devices and the ChipWhisperer target devices. The goal of these protocols is to both encode data and allow the target device to utilize the data in different ways by way of command field. In general, communication happens in the following steps. Host PC sends a packet using ChipWhisperer's Python API. Capture device sends this packet over UART. The target receives the packet and decodes it. Target utilizes the data in a callback selected by the packet's command field. Target optionally sends data back. target sends back an acknowledgement packet. There are two main versions of Simple Serial, version 1.1 and 2.1, as version 1 and 2 are both deprecated. Version 1.1 and 2.1 will be referred to as V1, V2 for the rest of this document. V1 is simpler, V2 is more complicated. V2 is much faster and has more features. V1 is simpler but less robust and transfers data slowly. In general, the API for V1 and V2 are designed to be as similar as possible. Simple Serial V1 can send a maximum of 64 bytes of data per packet. V2 can send a maximum of 249 bytes per packet. Python initialization. To initialize V1, to initialize V2, we have these different implementations. Okay, so we've looked at a custom firmware, not as much as we've looked at the Simple Serial document. So we have this custom firmware on ChipWhisperer targets document, which is also going to include the simple XOR cipher. So this is a helpful tab to reference. Simple Serial documentation is definitely going to be helpful. And this is another Simple Serial protocol. Something that tells us more about it. What is Simple Serial? How do we write source code? How do we trigger power traces to start and stop? So this could be helpful as well. There's not much to it on this page. Okay, so we're gonna have to pick a Simple Serial version. I've already picked version 2, but I was running into errors when I was working on this. So let me go ahead and pull up my current notebook, which I'm not sure where it's at. I must have closed it. So we're just gonna rerun it. Not a big deal. Right. Navigate into the ChipWhisperer directory and activate the virtual environment. And then navigate. So as you can see, everything here looks the same as before, except I have created a projects directory. So let me show you what's inside there. So I created a projects directory, and inside that is the XOR side channel project that I'm building. And currently I have this Python notebook. So I'm going to go back to the main directory, the root. I'm going to launch Jupyter Notebook just so we can have an interface. So everything is the same as before when I was working on the other labs. The only thing that's different is I created this projects folder, and then I also created another folder here within the firmware MCU directory, and that's here called Simple Serial XOR. And so I've attempted to create this experiment, but I've been running into some difficulties. So we're going to try to work some of that out so that we can get this experiment created. So I'm going to dive into the project's XOR side channel into this notebook here, because this is the actual experiment. So we want to use a custom XOR firmware on the ChipWhisperer Nano, capture power traces while the device computes, the cipher, which will be plain text XOR'd with a key. We're going to build a simple Hamming weight leakage model and correlate predicted leakage with measured power to recover one key byte. So right now, we've seen that with Simple Serial version 1, the library auto sends So I'm just going to go ahead and try to run this lab experiment so I can show you what error I'm getting. So we're importing the ChipWhisperer dependency, the libraries. We're importing NumPy, matplotlib, and tqdm.notebook. I think that's like a loading bar. Okay, so we're importing a progress bar loop shortcut with tqdm. We're giving our plot some kind of theme. We're configuring the hardware platform to be CW Nano. Now this cell block runs just fine. So crypto target is set to simple serial XOR. And the simple serial version is set to 2, version 2. This code block runs with no errors. So we've configured the hardware platform, and I referenced the Side Channel Analysis 101 lab notebook in order to create this cell. This next cell is a run block. It's going to navigate into the setup scripts that exist or that have already existed. We didn't create it. And it's going to execute this setup generic Python notebook to configure the ChipWhisperer Nano. so we know our device is connected. This is just going to print some information about our target and about the simple serial protocol we're using. So this next cell block is a make. It was right around this point where I was starting to run into errors. I think this should compile successfully. So simple serial version is set to version 2. We have the build log here. So we're using simple serial 2, and we know that simple serial 2 has the ability to send a maximum of 249 bytes per packet. I don't know where that will be something that we want to consider, but I think that is something to keep in mind. All right, so at this point, I believe is where the error occurs. So we want to program the Nano with our XOR simple serial firmware. So let me navigate back to our firmware folder into the MCU folder, and then the simple serial XOR folder. This is our simple serial XOR.c file. We have 3 functions in here. One is the main function, or we call platform init. And in this documentation here on side channel analysis using a simple XOR cipher, we pretty much just put the exact code block from here into our experiment notebook. So here a source file is made, simple serial XOR.c, that can accept a key and can also XOR that key with incoming plain text and send it back. Our project files typically support both simple serial version 1 and 2, but here we'll just use version 2. So we're using version 2. I feel like there may be some differences here in the file I'm using. Let's see. Well, at first glance it looks like so that is the case. Just want to put things side by side. All right. Static unsigned integer key, read key in, this is a different function name. So there's some differences here in the code that I made, in the code that's here. CMD, SCMD, len, data, pointer. Interesting, so we're returning 1. It's not equal to 16, return 1. Else, traverse through the length of the key. So I'm going to go ahead and just copy this exact code block and paste it into the firmware source code that I have in this experiment. And let's see, can I put this back in the tab? Nope. All right. So we have updated the simple serial XOR.c file. And we're going to go back to our laboratory notebook. So now we're going to program the Nano with our XOR simple serial firmware. We just made an update, so maybe that'll fix the error that I was having before. Let's go ahead and call that function, or the cell block rather. I think this one runs successfully. It might be this next one that provides us with some error. Now, when I was working on this yesterday, let me find the chat that I used. Okay. So we import and configure the constants in the first cell. So we import the libraries and configure the constants in the first cell, which is this top one. So what I'm going to do is put a mark down here and import libraries and configure constants. This should be marked down. Import libraries and configure constants. This next cell is our hardware setup using generic script. This finds the ChipWhisperer. It initializes the scope and target. And then sets clocks, gain samples. And the following we are programming the XOR firmware. Nope, never mind, not in this one. Right, so here we compile the XOR firmware. And then this is where we program the Nano. With the firmware. Okay. So this next cell just be a sanity check. We'll send a single plain text and see So we're going to set a single plain text and see if a ciphertext is produced. Alright, so as much as I would love to continue creating these markdowns, because it makes me feel like I'm doing something, ultimately I need to run this cell block. Because if this cell block doesn't work, then there's no point moving forward, or we just can't move forward because we don't know. We need to figure out what we need to do in order to move forward past this point. So fingers crossed. Well, I already ran that one. It's this one. Our sanity check. We need to see if our sanity check works. Okay. This was what I was afraid of. So we're not getting a ciphertext. We're getting some kind of unexpected start to command. Whatever this character is. Alright, so right after we run setup generic, we want to see what target actually is. So when we run this cell block, print what target actually is. Okay. So here I'm checking what kind of simple serial target ChipWhisperer thinks it has to make sure it matches the firmware version we just built. So here is our target object. We have class ChipWhisperer.capture.targets, simple serial, simple serial. So that's version 1. We've built the simple serial XOR for version 2. We want a version 2 target. So this might be creating the issue. Right where you currently. So this mismatch that we're seeing here because you can see right here we're setting this up to use version 2, but we're currently working on version 1. That's what our target thinks our ChipWhisperer is using. So we need to force generic to use simple serial 2. And from before, we did set it to version 2. Excuse me. All right. So we want to cleanly disconnect the old Simple Serial version 1 if it exists, and then recreate the Simple Serial version 2 target. So we'll go ahead and modify this current cell block. All right, so here we're going to cleanly disconnect the old Simple Serial version. And then we're going to set the target equal to just like that. And then we're going to print statements here. For the target. Alright, so let's see what happens. Takes one positional argument, but two are given. See why that is. Maybe it's incorrect. Incorrect API. Alright, so we're going to try a different method. Okay, well, it looks like we're on the right simple serial version now. We're no longer getting those strange characters. I'm genuinely very glad about that. So, I suppose when we were calling setup generic, we were setting simple serial up for version 1. So I believe if we run this now, getting some warnings and errors. Let's try reprogramming the ChipWhisperer with the firmware. Now that this simple serial firmware on the target is in its correct state, we can program the ChipWhisperer with the XOR firmware, if that makes any sense. It kind of makes sense. See if our sanity check is affected. So all right, I'm gonna take a quick break. All right. Where were we? Simple serial 2 is seeing one correct R character plus extra data that starts with 065. And it treats it as an invalid command. Now in our source code, it doesn't matter there. It's expecting a 72. So the host is complaining about extra bytes. We do have a real ciphertext value through the pipeline. I would like to clean this up though. So we're going to try 1 byte for our test. That doesn't do anything. getting tired. So some progress was made. At least we're getting a cipher text. So updated the firmware. Now we need to rebuild, compile the firmware. Now we need to program the board with our firmware. The E error packet is coming from symbol serial 2 itself, not from your handle or return values, because you've already because you're always returning 0 now, but still get this is the full packet. Okay, so we're just gonna add this and use this in here. See if that works. I'm beginning to reach a point of exhaustion. I may need to stop. Because I'm not making any progress here. making any progress here, and this is just getting in poor programming habits here. I just want it to work. I just want it to work so bad. I think this is where a good stopping point might be. device did not acknowledge. That's a problem. So firmware is encrypts and returns O1 for all the zero plain text. Simple serial 2 decodes and gives that ciphertext. After simple serial 2 sees an internal error, and log warnings, but it does not change the ciphertext yet. Simple serial is decoding multiple version 2 packets in a row. One of them is a valid. Alright, I think we're going to stop here and continue